Quotient rule example 2. Show that if y is equal to the square root of x over x squared plus x, then dy dx is equal to this expression, and then we want to state any values of x for which the gradient is 0. So starting with this, u is equal to x to the half. v is x squared plus x. So du dx would be equal to a half x to the negative a half, which we could write as 1 over 2 root x. dv dx would be 2x plus 1. So dy dx is equal to v du dx, so that's going to be x squared plus x over 2 root x, minus u dv dx, remember this is root x, so that's going to be root x, 2x plus 1, all divided by x squared plus x squared. So we've got this part of the denominator already. Now the fraction on top of a fraction is not good, so we need to multiply top and bottom by 2 root x. Multiplying top and bottom means that we're effectively multiplying by 1. If we multiply this term by 2 root x, the 2 root x's cancel, and we end up with x squared plus x. If we multiply this term by 2 root x times root x is x, so we've got 2x plus 1. And now we have 2 root x on the bottom, together with the x squared plus x all squared. And that's the correct denominator, so that's usually a good sign. So we have x squared plus x minus 4x squared minus 2x all over 2 root x, x squared plus x all squared. And that's going to give me minus 3x squared minus x over 2 root x, x squared plus x all squared. We can take out the minus x, and then we'd have 3x plus 1 over 2 root x, x squared plus x all squared, and that's the correct expression. Now we want to state any values for which the gradient is 0. For the gradient to be 0, the numerator has to be 0. But if we tried x equals 0, that won't work because the bottom is also 0, so that's just simply undefined. So the other value that makes the numerator 0 is if x is equal to negative 1/3. That would make this bracket equal to 0, and it wouldn't make the bottom equal to 0. So we can say dy dx equals 0 if x is negative 1/3.